URM, SM, and the different levels, etc. Now we're going into the test cases. We have 3 test cases. But first, an introduction of the test cases made by Ulf Carlsson, senior consultant at CAG, Syntell. Is that what you say?
Yeah.
Okay, you're welcome.
Så var det kameran.
Där kommer. There.
So, okay. I have been working the whole time in DVK 21 in 6 years, and we decided in November that we should apply test cases to verify that USM can function as it's supposed, even down to the shop floor, not only from the USM to the SRM that is at the high level, but that's why we created these test cases to, in some way, verify that the models of USM play good together and do what it's supposed to do. So that's a little bit what we will illustrate here. And I think it is one very important question, the different abstraction levels that we have. Because from the beginning, we thought that we have a model up here, and this model had a relationship with this model, and this model have a relationship with this model, and this model have a relationship with the implementation. But that was a wrong way of thinking.
Ulf, we cannot see you now. You're stepping outside of the camera. We can see you in the room, yeah. But can you try to use the...
Oh, we have the point.
On the top there. Yeah. Is it working?
Yes, yeah. Let me see them again.
Yes, we see you.
Yes. So I have been working with the models that Robert have created to implement them in Protégé as a kind of ontology. I am not an ontology expert, but I enter them, and there I start to look and see the relationships and realize quite fast that if we have here an implementation in a system, this is dependent on the levels above. So, and it's dependent on the levels here and also up here, because here up we have reference to the semantic rules and semiotic triangle. So we need to see this as an integrated model. That's why I call it a URSM template, ontology for a template, because the template is for all the models. So it's not so that you only start to work with this model and some other organizations start with this model and it must fit together all the way. That's why we have one template including all the models. Because it is a template. Because when you have an implementation of it, you use the same template, and then you implement it in different business contexts, as we see here in the different test cases, and each different context add their specific data. And the specific data for each context is their concepts at the SRM level, the concepts at the local company, and the information model that they use on the company. And here is the data models and the data that they use. That need to be added by the company itself and not the IT department. It is the business of creating and using the information that can never, ever, ever do help with, because it is the business people to need to actively add the information needed at different levels. So now we have a tool, a standard, a mechanism to support this work. It have not existed before USM. So now we really have the possibility for organizations to do this work helped by the structures provided by the USM models. And they do not need to see the ontologies and all the tricky things and mechanisms that we have inside here. They just need to know their information and their concepts and enter it. It's like driving an advanced car. You do not need to know how the machine in the car is built up. There's a lot of experts who know this. But the car driver needs to have a car driving license. He needs to be very good in driving the car, not knowing how the car is constructed. It's the same thing here. The people using URSM do not need to all these mechanisms that we have inside here. They just need to know their information, the concepts, and the data. That's an important part here. So here we can see then how different organizations can collaborate by having the information defined in the same way through the connected world. So, and it's a lot about models. First time when I'm approached models was with my first big 20 computer, 1983, reading this book by Lars Kristersson, Datorer, modeller och verkligheten. Computation quality depends on the models of reality quality. And I do not say computers, I say computation instead. Because we computate all the data in some way. But it depends on the models of reality quality. So that's why it's so important to create very good models, or good enough for the purpose of the models to be more correct. And whose models of reality is most real? We have a lot of models of reality at different levels, but what models do really represent the reality? Is it a standard model, or what model is it? But it depends on the quality of the models that we create, how close we can come to the reality. Today, I have found, by working with the ontologies and starting to understand what the ontology is and the standards behind ontology, that they really provide a very powerful language to discuss about information, a language for the information engineers, equal as medicine and doctors have a common language in Latin. We now have a common language by using ontologies for the information engineer to discuss and reason about information, data, and concepts. So I think this is a very big thing that we didn't have there, but not in relation to computers at least. And what was the questions for the different test cases? Because as I said, it is the business in the company, but how to map the company specific data, information, and concepts to the standards that we need and that we provide through URSM, because we need to use standards to express our information and data. And in test case 2, we use the PLC standard, because PLC standard have both a concept model and an information model. But how do the people in the company relate this?
I think that was the last slide.
Okay.
For the introduction.
Yeah. And how do we then, by having URSM implemented in a company, how will this change the way that we can access all the data that is addressed by URSM? It's a quite new way to access the data in all different systems that we have. And it's a lot of new tools. We heard about knowledge graphs here, and we have ontology tools, and we have taxonomy tools, and we have a lot of new tools that is based on World Wide Web standards, so it's quite open, but people is not so familiar to use and work with them. particularly, I have experience for 1 month of learning me how to use Protégé. So it's a new, also not at least graph databases that will become very important in this kind of future digital environment. And for us working with standards, as I said, very much of these tools are based on B3C standards, but we must take a look of which standards do they use, who do these standards fits together, how can we recommend to use different kind of standards, where can they be used. And these new tools, of course, need to be integrated in the present IT environment because you are working in your present IT environment. And then, at least, can USM represent all kinds of models in a unified way? As I had in the figure before, it's a lot of different models during the life cycle of a product. And if the product is a car, a truck, or a Navy ship, it's a huge amount of data in different kind of models. And that is the problem that USM really address. How can we integrate the data from different models? Because we need to have a comprehensive model to understand all the information about the ship. We cannot have isolated islands of models that not talk to each other. That is really the problem that USM address, if implemented and used in the correct and intended way. And that is the most importantly. So that was my introduction to the test cases.